Hi everyone, it's Mrs. Matson. Today we're going to talk about multiplying decimals. By the end of today, you will be able to fluently multiply decimals. So I'm going to start off by giving you some tips. Tip number one is forget everything I told you about adding and subtracting decimals and lining up the decimals. That's not needed when we multiply decimals. So instead of lining up your decimals, we put everything like as far left as you can get. So with these numbers right here, 456.9, and then I want this to line up, the second number to line up underneath it. So I want them both to be lined up right there. That is tip number one. Forget about the decimals. In fact, once you have it set up, you can ignore the decimals completely and treat it like you're just multiplying regular numbers. Super nice, huh? Tip number two is put the smaller number on bottom. The commutative property says that if everything's being multiplied, then it does not matter the order that you put these in. So what I mean by that is if you have two numbers, let's say 24 and 742 that you're timesing, you could times it like this. You'll get the same answer as if you do it this way. There's just one way that I feel like is a lot easier to do, and that is this way. Because this way you'll times everything by 4, put it here, times everything by 2, get it here, and then add it up, and you're good to go. Okay, with this other way, you have to times everything by 2, times everything by 4, times everything by 7. You end up having to have 3 partial products to add up instead of just 2. So always try to put the smaller number on bottom. It won't change your answer, but it'll just be easier to solve. Tip number 3. In order to put the decimal in the correct spot after you have completed the multiplication, you count the numbers behind the decimal. So once you finally worked the problem all out, then you look at the decimals and you count how many numbers are behind those decimals. In this case, there were 1, 2, 3, 4 numbers behind the decimal. So you're going to scoop that many numbers in to get an answer of 15.5346. So that is what I think is the easiest way to get that decimal in place. Once you have it set up, you can ignore the decimal, and then when you get your final answer, then you can scoop the decimal back in, okay? And the final tip for you is if you end up having like a 0 at the very, very end, after you have a decimal, that 0 means nothing, and you kind of can completely ignore it. Why? Well, $2.70 is the same as $2.07. So get rid of these zeros. It'll make it a little bit easier to work with. All right, here is the first problem, 22.5 times 8.4. I'm going to set it up, 22.5 times 8.4. You might be like, well, Mrs. Manson's those decimals lined up. Yeah, sometimes they will just coincidentally, but what I'm really making sure is that those two numbers are lined up as far to the left as they can go, to the right as they can go, okay? And now, honestly, I can completely forget about those decimals until the final step, which is to scoop the decimal in, okay? So basically what I'm going to be doing is I'm going to start by timesing everything by 4. I'm basically going to do 225 times 4, okay? So 4 times 5 is 20. 4 times 2 plus this 2 is 10. 4 times 2 is 8, plus 1 is 9. So basically what I found out is that 225 times 4 is 900. Now I'm going to times everything by this 8. But we can kind of see that number's not really 8, is it? It's actually more like it's 80. And so now my next partial product is going to be me doing 225 times 80. And we know that if we have a number like 6 times 80, that I can just go 6 times 8 and put a 48 and then put a 0 at the end, correct? So that is the same when we are doing multi-digit multiplication, is that 0, I can just put there, put that at the end, and then solve everything through. That is why when you're doing it, you will always put a 0 right there to begin with. And then you can multiply it like normal. 8 times 5 is 40. 8 times 2 is 16, 17, 18, 19, 20. And then 8 times 2 is 16, 17, 18. Okay, so I just found out that this is 18,000. 80 times 225. So the last thing I'm going to do is add those two together. And I'm going to do that right here. I've got that. Now the last step is to put that decimal in place. I'm going to put that decimal in place by counting how many numbers are behind those decimals. I can do it there, or I can see that there's a number behind a decimal. There's a number behind a decimal. There are 2 numbers behind decimals. That means I'm going to scoop the decimal 2 times in. Now there's not a decimal here, and what I like to say is if the decimal's not in sight, then you put it on the right. It's kind of one of those invisible math things that there's always a decimal at the end. Most of the time it's just invisible. So start with the decimal on the right and then scoop it 2 times in. We get an answer of 189.00, right? Now, remember that tip where we don't need zeros at the end? That's because if we think of this as money, $189.00 is the same thing as just $189. So we're okay with saying that the answer is 189. You okay with that? Okay, now let's not forget the important part of estimating to make sure our answer makes sense. And estimating while multiplying is really quick. Okay, I can just change that to 20, change that to 8 or 9 or something close to that. And then we see that 0 at the end again. So I know there'll be a 0 there. 2 times 8 is 16. My estimate was 160, which is very close to 189. So that's a quick way for me to check to see if I did it correctly. It could be that if I had forgotten to put my decimal completely and I were to have said, oh, my answer is 18,900, I would have had 18,900 and looked at my estimate and been like, oh boy, I definitely did something wrong. And then I can go back and be like, oh, I forgot to scoop twice to get my decimal in. So estimating is a great thing to do. It's quick and it helps you know if your decimal's in the right spot. Okay, let's try one more. If you want to try it on your own, pause it and then check my answer. If you're not feeling super confident, then let's do it together. Okay, now you might be like, this is the longer number, it should go on top, but like it really is only like 2 numbers, the 4 and the 3. We really don't care about those. Zeros are easy to multiply with, right? So I'm going to keep the 1 and 21/100ths on top and the 43 on bottom. And in fact, I'm going to completely ignore those zeros and decimals and just bring the decimals in at the very end. Okay, that makes my numbers look a lot cleaner. And so again, what I'm going to be doing is 121 times 3 and 121 times 40. Those are going to be the 2 partial products. They're just going to be stacked up right there instead of out like this, okay? So let's have at it. 3 times 1, 3 times 2, 3 times 1. Okay, so 363. Then let's go, oh, put the 0 there, correct? Because that's where that is. 4 times 1, 4 times 8, and 4 times 1. Add those up. And I get 8, 9, 10, 8, 9, 10, 11, 12. Carry that and I get 5. Okay, now let's look back at those decimals. I got a decimal here and a decimal here. That's a lot of numbers behind the decimals. 1, 2, 3, 4, 5. I'm gonna have to scoop 5 times. So let's start at the right. 1, 2, 3, 4. Can I keep going? Yes. Oh, look, it turned into a line. Go away, line. Let's scoop again. 1, 2, 3, 4, 5. If you end up needing to put zeros, then that is totally okay. Another trick is if you start with a decimal, put a 0 in front. That way it makes that decimal a little more obvious instead of like, sometimes it's hard to see, but if it's a 0 with a decimal, it's a little bit easier. So the answer is this very, very, very small number. Does that make sense? Yeah, you have a 1 here, and you're timesing it by a very, very small decimal. So it makes sense that our answer is pretty small. Okay, that one's going to be a harder one to estimate. Just kind of know that 1 times a very, very small decimal is going to give you a very small answer, which is what we got. Okay. All right, friends, let's move on to a story problem. Last summer, Rachel worked 38.5 hours per week at a grocery store. She earned $9.70 per hour. How much did she earn each week? So if it was $9.70 every hour, and she worked for 38 and a half of those, that means it's $9.70 plus $9.70 plus $9.70 for every hour, right? So that tells me it's a multiplication problem. I want to go $9.70 38 and a half times. Okay, so one way that I could write it is 38.5 times 970. We can make this problem easier by getting rid of that 0. So now it's only 2 numbers instead of 3. Okay, so let's write that the way that we can solve it. And let's put the 38.5 on top and then 9.7 on bottom. I'm totally okay if you pause this and try it on your own and then come back and see. 7 times 3 is 35. 7 times 8 is 56. You want to know my 7 times 8 trick? 5, 6, 7, 8. Do you ever hear dancers say that? 5, 6, 7, 8. 56 equals 7 times 8. There we go. It's showing up. So if you don't know what 7 times 8 is, then I want you to turn into a dancer and go 5, 6, 7, 8. And you'll be able to remember that 7 times 8 is 56. That's how I remember it. I don't know if it'll work for you. Let's go back. So right here, 7 times 8 is 56, 57, 58, 59. 7 times 3 is 21, 26. Okay, so now I'm going to times everything by 9, but I'm going to remember that it's actually 90. So I'm going to put that 0 there. 9 times 5 is 45. 9 times 8, 72, plus 4, 76. 9 times 3, 27, plus 7, 27, 28, 29, 30, 31, 32, 33, 34, 34. Add that up. Let's do a different color to make it pretty. 14, 12, 13, 6, 7, oh, and 3. Okay, so I end up with, could it be possible that she made $37,000 in 1 week? Possibly, but she's probably making more than $9.70 per hour. So let's not forget about our decimal. Here's our decimal. So there's 1, 2 numbers behind the decimal. So I have that she made $373.45. Ourselves of the tips. Don't line up your decimals. Okay. To get the decimal place, remember to scoop however many numbers are behind the decimals, and have fun. Practice. Get that trail in your brain paved with a lot of practice, and I will see you next time. See you.